So I'm going to be speaking about the how and why of flexible React components. As mentioned, I am Jen. I am a senior front-end engineer based out of New York. If you want to reach out to me on Twitter, my handle is girlcode with a U. So I love React. I am a die-hard fan. It's really the first JavaScript framework that aligned with how I want to write UI. And I've been writing it for 4+ years now. So when I thought of what I wanted to share in this talk, what I've learned over those years about working with React to build flexible components, I knew the technical part of this talk really well, and that's the how. But what I was forced to articulate as I wrote this talk is the why. I knew why to a degree, but I hadn't really sat down and written it out before. So to start, let's think about why do we care if a component is flexible? And what does flexible even mean? So in terms of building UI, flexible is often meant as reusable. So say you're tasked with building a UI component, and it doesn't really matter what it is at this point, so I'm just going to represent it with a block. OK, so we have our block. It has 4 sides, 4 corners. Beautiful. So when we get a new design with that same UI element, we feel really good because we've already built this. Sure, these 3 elements are all different colors, but each shares the same structure as our block. So we can reuse it. Except, something did change. OK. So the functionality of the block actually did change. You can see that one has a tooltip now, so it's a little different. So when you hover on it, a tooltip is going to appear, and we're like, OK, yeah, that's fine. Sometimes it's got a tooltip, so we're going to add a with tooltip prop to signify that. Things are still OK. Oh, yeah, OK. So a few weeks later, we get a different mock, and now this time it's got a dot inside of it. OK, cool. We'll add a with dot prop. We're still OK. Still OK. OK. And again, later, same block, different requirement. So we're going to add another prop. So is this component flexible? It's being reused. We can change what UI it represents with a prop. So that seems flexible. But let's imagine that some time goes by. Maybe we've stopped working on this component, but our coworkers are working on this component. And they're going to add to it because it's a reusable component. And the changes are just a little bit here and a little bit there. And why rewrite all of this when we could just reuse that component by adding some props? Oh, and don't forget, we're going to add some A/B tests in there. So let's add that in too. It's going to be temporary, we think. It's the dreaded apropcalypse. Our simple block component is now overrun with props. So what now? Is this component still flexible? Nothing has changed about its reusability. It's still handling multiple UI states based on what props you provide. But I'd argue this isn't a flexible component, and that our idea of reuse can sometimes blind us to better, more flexible patterns. Now, I've dealt with a component like this before, and I'd guess most of us have. Blessings upon you if you have not. May you never have to. The example I use about the block component is drawn from a real example at a code base I used to work in. And we had this component called the call to action. And this company that I worked for dealt with a lot of schedules. So you would buy a subscription for us, and then you could book various classes with us. So our UI was composed mostly of schedules. And you could interact with those schedules by using the call to action. Now, it was one of the very key components, and it was deceptively difficult. So it was just surprisingly complex. It had 5 different states. I'm only showing 3 up here, but it had 5. So if you were viewing schedules as a logged out user, you'll see a join message prompting you to sign up. If you were logged in, you would see one of 3 different messages. So how many credits the class was going to cost you to book, a cancel message if you had already booked the class, or maybe you couldn't reserve that class at all and we need to show a disabled state. For instance, if you had already reserved a class at that time, we need to show a grayed out state to let you know you couldn't then reserve another class at that time. And then if you had, had a membership and then canceled it with us, we were going to show you a reactivate message. And it also had 3 different behaviors. So it might open a modal, it might link to another page, or it might show a tooltip. And to correctly determine which CTA to show, this is all the information we need to know. So, is the user logged in? Yes or no? What's the state of the user's subscription? Are they subscribed, unsubscribed, or canceled? And what's the state of the class? Is it available, unavailable, reserved? When I joined the company, the schedule CTA actually already existed. So I first encountered it when I needed to implement it on a new page. And you can see as I scroll that this component is fairly complex for a button. It contains if-else statements, a switch statement, various functional components, and so on. And the history of this component is similar to the block example. It was created with a smaller initial scope, a button that users click on to reserve a class. And from there, more intricacies were laid on top. Yeah, it's still going. So a tooltip, links to other pages, permission checks for A/B tests, various designs based on state. This was a really complex component. By the time that I actually needed to implement this component, it required 14 props. 14 props. No matter the use case, you needed to pass in 14 props for this component to work. And God help you if you needed to add another prop, or you forgot a prop, or you need to change anything about this. So is this component flexible? The thing is, you can write reusable components that are inflexible. Reusable doesn't equal flexible. Yes, the schedule CTA is reusable, but what happens when it needs to change? Which prop can you safely take away? Which prop is needed for what UI state? And these questions are really difficult to answer because the component itself is difficult to understand. And if you can't understand it and you can't safely modify it, is it flexible? I would argue that flexibility is about more than reusability. It's about the ability to understand and to augment. To me, that's true flexibility. I don't care if your component is used in one place on your site. If I can understand it and change it with ease, that's a flexible component. The opposite, unable to be understood, unable to be modified, those qualities make a component inherently inflexible. But now I need to stop talking about what I mean, and I need to show you what I mean. So we're going to refactor the schedule CTA. And we're going to start with, hands down, the best starting point for writing a new component or refactoring one. We're going to write down our ideal API. So React is declarative, and this is awesome. We can start from a point of not how we're going to create this component, but what we want it to look like. And this is an important part of building a truly flexible component. Often, we focus on how we'll make a component reusable when we should be starting with what it should look like and then let that inform how we implement it. So for example, the schedule CTA. If we focus on how we're going to render different CTAs into one component, we're going to go down a path we've already been. If-else statements, switch statements, one long giant component. And that's all imperative, it's not declarative. So let's focus on what we want it to look like. Our ideal API is one prop, the type. So that's the entire job of this component. I give it a type, and it gives me back the appropriate CTA. And this is a significant change for this component, and I don't mean in terms of the number of props that are passed in. We've made a fundamental change to the structure of this component because we just pulled the logic out of it. So previously, the schedule CTA needed those 14 props to decide what CTA to show. It had embedded business logic that required all of those props. And this is a problem for some very good reasons. If you add business logic to a component, you've locked that component. It can't be reused with a different set of rules. Which means you need to understand the logic to use the component or to change the component. And if you want to change the logic, you'll probably need to add more props. This is where we get into the apocalypse. So, by removing the business logic from our components, we're going to gain flexibility. We can understand and we can augment with much more ease. And we can also reuse that component with a different set of logic rules. Since our ideal API removes the need for embedded logic, we can pull it out into a separate function like this. And we no longer need 14 props. Apocalypse avoided. Plus, centralized logic is easier to reason about. And we can also test the component separately from our logic. But isn't it nice to have one component that just does it all? Maybe, sometimes. You know, magic can be a really lovely thing. Something that just works can be really wonderful. But I want you to think about what level of magic you're aiming for. Do you want a rabbit in a hat, or do you want a vanishing elephant? You don't want so much magic that the engineer can't figure out what's going on. The more magic, the less flexible the component is. Since the schedule CTA was vital to that application, I wanted very little magic. That's part of why I chose this API. I want to give the engineer who uses this some clarity about what's going on. Give the schedule CTA a type, get back a CTA. But I also just wanted a simpler API. You know, I'm aiming for engineers to use this component. I want them to be able to safely navigate it. And I want to not be kicking myself for code I won't be able to understand after a few months of not looking at it. So now we actually get to decide what to do with the CTAs themselves. And we've got some options here. So option one is that we're going to use a base CTA component, and we're going to change out the messaging and the props based on the type. And then option two, we're going to write each CTA type as a separate component. So there would be a reserve CTA, a cancel CTA, so on and so forth. Now, if you're leaning towards option one, you might be thinking that since all the CTAs look similar, you could get some reuse out of a base component. Less duplication of code, one place to update. This sounds good. But each of these CTAs needs to be modified depending on the type. So, for example, the join CTA is a link, but the reserve CTA is actually a button. So are we heading for another apocalypse, trying to reuse one component for all of these? And if you're leaning towards option two, you might be thinking that since the CTAs don't all share the same UI or same behavior, it makes sense to break them into separate components. You'll know where to make changes, and you can isolate behavior to a particular CTA. But you'll see some duplication of code. You might need to update each component at some point, and that's definitely a pain. And truthfully, between these two options, I don't think there's a right answer and a wrong answer. I think there's just options with upsides and downsides. And ultimately, I chose a third option. So I want a base component that handles some of the common UI, but I want to break the CTAs out into their own components where I could specify some behavior. So this is the base CTA component. I really just wanted it to be lightweight because its main job is to encapsulate the parts that might change more frequently, like the class name. But I also needed it to not interfere with the differences between the CTA components. Like the fact that some CTAs are buttons, others are links via React Router, and others are A tags. So I'm going to take advantage of defaults in ES6 here and assign the button as the tag. But any specific CTAs that need a link or an A tag can override that. And I like this because I get to encapsulate the most commonly used tag type, a button, and when we override it, it's going to be clear that the CTA we're passing, it's going to be clear that we're modifying that CTA because we're passing along a specific prop. And I'm also going to be relying on the children prop to render the different CTA messages. So children is super useful for when you need a generic container to take in more specific child components. And just a really quick example of this is this fake bread component. So it's our generic container. It's going to take in the children, this.props.children. And then whatever we put in the bread could be different. So, whatever type of sandwich or burger you would like. But that's the basic usage of props.children if you're not familiar. And as an alternative to using the children prop, we could have passed in a message prop. But I find that less useful for this type of component. So one thing is, at the company, we were using React International. So for these various messages, I would actually be passing in a component, not a string. And when you're doing something like that, passing in a component via a prop, I'd urge you to consider using children instead. It's more flexible. It's a more declarative option. You can change the children components, the internals of the container, without needing to actually change the container itself. So for our uses in the schedule CTA, we only need to know that whatever we're going to wrap the base class around will be available as the children prop. So here I'm wrapping a formatted message component from React International to show the credits it's going to cost to reserve a class. So we're taking a generic component, the base CTA, and giving it a specific children as well as specific props, like the button primary class name. And I can also make sure that I have specific behavior. So since the disable CTA doesn't do anything when a user clicks on it, I can ensure that the onClick handler, even if accidentally passed a prop, never gets called. So as an engineer, this is really great because I can specify behavior per component. So when the join CTA needs special analytics tracking, I can do that without touching anything else. And since the reserve CTA needs to open a modal, I can do that, and I don't need to worry about accidentally introducing a change to the component. I can test each of these CTAs for the behavior specific to them, and changes to the CTA are going to be isolated to that particular CTA component. And we've also added some flexibility that wasn't there before. So now we can use the CTAs alone. Now, this is the page for if you had upcoming classes, and since a user has already reserved these classes, all we want to show is the cancel CTA. We don't actually want to use the schedule CTA button here because we already know the state of all of this, which is that they've reserved the class. We just want to show the cancel CTA. And we couldn't do this before because the schedule CTA was the one that decided what to show. It wasn't the other way around where I was giving it a type. It had that embedded logic in it. But now we have these lovely separate CTA components to use as we wish. So now that we have our base CTA used to create individual CTA components, but we also have the schedule CTA, and it's actually not complete yet. We're going to give it a type, and we have individual CTAs that we already created, but we need to actually figure out how the schedule CTA is going to take that type and then return the specific CTA that you requested. Now, we could use a switch statement inside schedule CTA to return the correct CTA. That's totally valid. But looking at our ideal API, I think I see a better option. So we're going to give the schedule CTA a type, and it's going to give us back the correct component for that. And this reminds me a lot of requesting a key from an object. So let's use that pattern. We'll create an object with keys and values that correspond to the type and its component. And now we'll use the type prop to grab the correct component to render. Now, if you're wondering why I'm assigning this to component with a capital C, React allows you to dynamically render components, but the component needs to be capitalized. And this allows React to tell the difference between a built-in component, like a div or an A tag, and a user-defined component, like our CTAs. And dynamic component names are a nice method for cutting down on switch and if-else statements in your component. So here, I'm using it to decide which sidebar I would like to show. And then here I'm using it to decide if I want to wrap the content in a card or not. I use this a lot in my various components. And then this is the schedule CTA after our refactor. So this is much smaller. You'll notice there's no scrolling. Very, very small. And all it does is it expects a type. And if that isn't provided, we're going to return null, because we have no option to return to you there. But if we do have the type, we're going to use it to grab the correct component, and we're going to assign it to the dynamic component name. And then we're going to pass along our remaining props to that component. Oh, but wait, what are these other props? I thought we were just giving it a type. Well, you know, our ideal API was just the type. And I kept calling it ideal because it's going to change. We're going to need to provide some more props to it. So for example, we should add in a class name so engineers can customize the styling. So we always start with the ideal API, and then as we build out the component, we're going to start to layer in the more realistic API. And this is the realistic API. This is actually what's in that code base. So we've gone from 14 props to 4. And most of the schedule CTAs, they actually need a little bit of the schedule information. And then we pulled out the tooltip into another prop that you may or may not pass along a tooltip value to. But this is dramatically smaller, as you can see, and also way more readable and understandable. So after this refactor, we can use whatever logic we want. We can use individual CTAs alone. And then we can add and remove the CTAs with ease. Because we're using that object pattern, it's actually very easy to add in another CTA type, especially for like an A/B test, or remove it later when we need to. And then this is everything that happened after I refactored that component. So refactoring was actually totally worth the time that it took. We added and removed A/B tests. We actually removed the disabled CTA on some pages. The class names absolutely changed. Messaging for the reserved CTA changed. And there was also asked for specific CTAs on specific pages. We actually couldn't do any of this with the old schedule CTA. It would have been a complete nightmare. And trying to do all of this with that would have probably added more props. Now, of course, I want to caution you that everything I've shown you in these talks, these patterns that I've shown you, how I did this, all of this is just tools in your toolbox. This is how I decided to refactor that component and make it more flexible, and some general advice on how to do that, like writing out the API. But these are just tools in the toolbox. You don't have to do everything I'm showing you. I'm often really guilty of seeing a pattern, and then I want to apply it to everything. You give me a new React pattern, and I'm like, yes, all the things. Do it to everything. You know, but this brings me to a part of the talk that actually I really hadn't expected to write. I thought this talk would be mostly technical, but in some cases, the why of building flexible UI isn't tied to the technical. It's about how you approach code as an engineer and how that impacts what you write. So I have this ongoing joke with a friend of mine. He really loves lifting things. I know that sounds really weird, but he lifts weights as a hobby, and so he actually enjoys lifting like anything heavy. Like, he will carry my luggage, he will offer to help you move and be sincere about it. You know, he really does. And it's super easy. If something's really heavy nearby and he can lift it, he's like, I'm gonna go lift that thing. And one day I was like, you know, it would be so easy to trap you. Like, it'd be so easy for me to put a dumbbell on the sidewalk, just wait for you, and then throw a net on you. Like, I could catch you so easily. And it started off as this joke where I was like, dude, you gotta know your traps. You gotta know what someone could place on the sidewalk in front of you. You would go instinctively for it, and they could totally trap you. And the more I thought about it, the more I realized that this was part of also being a flexible engineer. So you need to know your traps. One of my traps is that I see a new pattern and I want to apply it to everything, when I should be waiting for a use case that makes sense for it. And you might also have some traps yourself. You might do that same thing too. Or maybe you're actually very hesitant about new patterns or new ideas in React, and you're very timid about approaching them. These things are all actual traps. They will keep you from writing better, more flexible components. And then once you've written those components, are you willing to kill them? So I come from a background of creative writing, and kill your darlings is a really popular statement in the creative writing community. What it means essentially is that if you've written some part of a story or poem that you love, whether it's a character or a word or a line, you just adore this thing, it's your creation. Does this sound familiar, by the way, at all with components? You have to be willing to sacrifice them for the overall work. Because sometimes you've written a character that doesn't work, and sometimes your line doesn't work, and sometimes your word isn't the right one. And in a lot of cases, the things that you're going to build as engineers aren't going to work in the long term, and they may not even work in the short term. So how flexible are you? Can you kill off your darlings? I feel very attached to the components that I write. This schedule CTA is off at another company now. Sometimes I wistfully think about the engineers that are now touching it. But I have to be okay with the fact that someone's probably going to kill it. Someone's probably going to modify it. And sometimes people are going to come in with better patterns than I had ever dreamed of. They're going to come in with things I've never seen, and I need to be willing to be flexible and to adopt those things. So, really quick summary. What we learned today, we're going to start with our ideal API. We're going to layer in the realistic API as we go. We're going to let that API inform the component design. We're going to decide what level of magic do we want. Now, business logic, kill it. And be flexible as an engineer. Know your traps and kill your darlings. Thank you.